ஹலோ ஃப்ரெண்ட்ஸ். ஸோ இன்றைக்கி நம்ம என்ன பார்க்க போகிறோம் பார்த்தீங்க அப்படின்னா, ஸோ எலக்ட்ரிசிட்டியில் முக்கியமான லா ஹோம்ஸ் லா. ஸோ வி ஆர் கோயிங் டு see a beautiful wonderful topic which is called as ஹோம்ஸ் லா. ஸோ பிஃபோர் மூவிங் ஆன் டு ஹோம்ஸ் லா நம்மளுக்கு சில விஷயங்களை தெரியணும். ஸோ வாட் ஆர் த சில டைப்ஸ் சார் அப்படின்னா, ஃபஸ்ட்டு வி ஆல்ரெடி நோ வாட் இஸ் கரண்ட். வி ஷுட் நோ வாட் இஸ் கரண்ட். ஸோ வாட் இஸ் கரண்ட்? Current is nothing but what? Flow of charges in a cross-section area of a conductor. So it is a cross-section area of a conductor. So ஒரு கண்டக்டரில் எனக்கு ஏகப்பட்ட n number of electrons இருக்கும். அதில் எந்த அளவுக்கு எனக்கு charges மூவ் ஆகுது, அதுதான் we called as what? Current. So that's why we called as, it is represented by letter I. So and also for current we have a formula. What is that formula? I is equal to Q by T. I is equal to what? Q by T. So we write also like this also. So del Q by T. So changing charges produces what? Current. Okay. So flow of charges is nothing but what? Current. And next we are going to see about what is voltage. Voltage is nothing but electrical pressure applied to move an electron from one end to another. For example, if the electrons should move from this positive end to, and they have to travel all the way along to reach the negative terminal. Okay, so this is called as what? Higher potential in solvom. This is called as what? Lower potential. So electrons, okay, so this electrons will move always from higher potential to lower potential. This direction is taken as a electric current or a direction. But இதிலே electron current இருக்கு. இந்த electron current அப்படின்றது எனக்கு என்னது? It flows from negative to positive. It flows from what? Negative to positive. நல்லா ஞாபகம் வச்சுக்கோங்க. If the current is flowing from negative to positive, then we call it as a what? Electron current. Okay, when it is flowing from positive to negative, then we will call it as a electric current or conventional current. We will see this topic in upcoming chapters. Okay, so what is conventional current? Okay, so conventional current is a thing which always flows from positive to negative direction, and electron current is from negative to positive direction. Why did I told you now? Because what is voltage? Voltage is nothing but moving of electron from one end to another end is called as what? Voltage. And it also represented by letter what? V. Okay, so it is measured by a thing is called as voltmeter. Okay, so then we are moving to the resistance. So what is the resistance? Resistance I already told you, it is nothing but what? Property of a material. Property of a material. You according to this property or according to this material, the resistance can be changed. So material மாற எனக்கு என்ன ஆகும்? So resistance எனக்கு என்ன ஆகும்? Change ஆகும். Resistance எனக்கு என்ன ஆகும்? Change ஆகும். Okay, so resistance is represented by letter R and it is measured by ohm meter. Okay, for this resistance we have an important law. What is that law? Resistance is equal to, what is that law? Resistance is equal to resistivity L by A. Correct. So resistance is directly proportional to length and inversely proportional to area. If the length of the conductor is more, resistance is also more. If the area is less, resistance will be more. If resistance is less, area will be if area is less, resistance will be more. If area is more, resistance will be less. According to that it will change. Okay, so area அதிகமாக இருந்ததுன்னா ரெசிஸ்டன்ஸ் கம்மியாக இருக்கும், ரெசிஸ்டன்ஸ் அதிகமாக இருந்ததுன்னா ஏரியா எனக்கு ஆப்வியஸாக கம்மியாக இருக்கும். பட் இந்த லென்த்தை பொறுத்த வரைக்கும், if length is more, resistance is also more. If length is less, resistance is also less. So this is the main important law of resistivity. To take this constant proportionality, we add a resistivity constant which is called as rho. Okay, so இதெல்லாமே நம்மளுக்கு லாஸ்ட் டாப்பிக்கை we have seen this. கரெக்டாக? ஸோ இப்போ நம்ம எதை பற்றி பார்க்க போகிறோம் அப்படின்னா, முக்கியமான law, that was a scientist who derived a relation between voltage and current. ஸோ வோல்டேஜுக்கும் கரண்ட்க்கும் இருக்கிற வித்தியாசத்தை பற்றி, ரிலேஷனை பற்றி, வித்தியாசம் இல்லை, இட் இஸ் அ ரிலேஷன். ஓகே, வாட் இஸ் வோல்டேஜ் அண்ட் கரண்ட் அப்படின்ற ரிலேஷனை பற்றி சொன்னவர் தான் ஹோம்ஸ் லா. ஸோ ஹோம், ஓகே, வாட் இஸ் ஹிஸ் நேம்? ஹோம். ஹோம் இஸ் யூஸ்வலி he determines the relation about everything. ஒரு கரண்ட்டுக்கும் ஒரு வோல்டேஜுக்கும் எனக்கு என்ன ரிலேஷன் அப்படின்றத எனக்கு என்ன பண்ணார்? ஹோம்ஸ் தான் எனக்கு என்ன பண்ணார்? டிரைவ் பண்ணுறாரு. வாட் இஸ் ஹோம் சேயிங்? ஜென்ரலி ஹோம் என்ன சொல்கிறார் அப்படின்னா at constant temperature, okay, remember that at constant temperature what is saying, current is directly proportional to voltage at constant temperature. அதே எனக்கு current at constant temperature is inversely proportional to resistance, okay, inversely proportional to resistance in a circuit, okay. For example, இப்போது எனக்கு லைட் பல்ப் எடுத்துக்கோங்க, நம்ம வந்து யூஸ் பண்ணுறோம் பார்த்தீங்களா, இந்த இன்கேண்டிசன்ட் பல்பு, குண்டு பல்புன்னு சொல்லுவோம் கரெக்டாக. இந்த குண்டு பல்ப் எடுத்துக்கிட்டிங்கன்னா நீங்கள் ரொம்ப நேரம் வந்து இது படுத்திங்கன்னா உனக்கு ஹீட் ஆகிட்டே இருக்கும் கரெக்டாக இல்லையா. ஸோ இந்த இடத்துல எனக்கு என்ன ஆகுது, டெம்பரேச்சர் இன்க்ரீஸ் ஆகுது. அப்போ டெம்பரேச்சர் இன்க்ரீஸ் ஆன இடத்துல எனக்கு ஹோம்ஸில் அப்ளிகபிள் ஆகுமா சார்? It will not applicable. When there is a constant in temperature only Ohm's law is applicable. When there is no constant in temperature, temperature is either increasing or decreasing, means then there will be no applicable of Ohm's law. So this is the main important thing. So always this Ohm's law is always depend upon a constant temperature, okay. So what is that formula of Ohm's law, sir? Na V is equal to I into R. So this is the Ohm's law oda formula, okay. So what he said, if at constant temperature current is directly proportional to voltage and inversely proportional to 1 by R, okay. So நான் என்ன எக்ஸ்பிளைன் பண்ணியிருக்கேன் அப்படின்றது இங்கே கூட நீங்கள் வந்து ஒரு வாட்டி பார்க்கலாம். Listen, Ohm's law holds and provide temperature and other physical process remains holds true when there is constant temperature, but in certain components increasing the current raises the what, temperature. So you know, so for a long period of time, if I am just making a light bulb to work for 2 hours 3 hours, automatically temperature rises, okay. In that light bulb you can see that current also increases. When temperature increases, current also increases. Here Ohm's law cannot be applied because the light filament violates what, Ohm's law, okay. So Ohm's law is applicable only when there is a constant temperature, okay. At that time current will be directly proportional to voltage and and resistance will be inversely proportional to the current, okay. So this is Ohm's law, okay. The next topic we will see what is the relationship between voltage, current and resistance, okay. Now can you see this diagram? So in the first diagram you can see that there are 2 batteries and 1 bulb. If in 2 batteries we are taking as a voltage 3 and Ohms is equal to 6 and the current is equal to 0.5, we are putting according to this formula V is equal to I into R, okay. So in this you can see that here I have applied 6 voltage, resistance also 6 ohm, but current has been increased from previous one. You can see here 9 volt, inga pathina 9 volt irukku. So same 6 ohm, you can see the current is increased here. Likewise if you apply the same voltage here, inga 3 voltage iruka, okay, you have the same 3 voltage, but now the resistance is changed, okay, resistance is doubled. Now you can see the current is been reduced, correct ah. இப்போ next பாருங்க, அதே மாதிரி இங்கே பார்த்தீங்கன்னா 6 voltage அதே 12, current எனக்கு என்ன ஆகுது, கம்மியாகுது. அதே மாதிரி voltage resistance அதிகமாகுது, current எனக்கு என்ன ஆகுது, கம்மியாகுது. So you can see that from above the diagram what you are explaining, when I increase the voltage, okay, when I increase the voltage, what happens here, when I increase the voltage, okay, current also increases. The same wise resistance is also increasing, correct. If resistance increases, current will be reduced. How, sir? You can see I equal to V by R. Can you see this? When current is been increased, resistance is been decreased. When resistance has been increased, current is decreased. In all these cases, can you see this? In this first case there is a 3 voltage, inga pathina 3 voltage da we have applied. Now resistance is 6 ohm, you can see 0.5 ampere of current. The same thing ingeyum 3 volt da, but the resistance is more inga, appo inga na the current, so it is reducing to quarter. So the half means it is what, quarter. So this is how it is relating, okay, what he is saying, okay. So this is how we relate. Next we are analyzing Ohm's law in a water pipe analogy, okay. Imagine ஒரு சின்னதா வந்து ஒரு story மாதிரி I will tell you. take a water tank. Okay, take a water tank. In this it is filled with water. Okay, filled with water. Imagine this flow of water is nothing but current. Okay, nothing but current, and there is a pipe I have attached where the water can flow, so where the water can drive. So this drive, imagine it as a voltage. Okay, imagine if there is some resistance. Imagine there is some sand has been stuck into this pipe, or else imagine it is a metal pipe. Okay, due to water flowing it has been rusted. Okay, it has been rusted and become weak. Or else imagine there is a spit of sand is attached to this pipe. Okay, can you see this? Here the water flow will be very less. The water flow will be very less due to the lag of due to the lag of some dust. Another same tank I am having in this side, there is no, okay, there is no lag and the water is flowing very easily. Okay, so this water is considered as a current. The driving force is considered as a voltage, and the thing which resists the water, okay, that sand or some or something rusted material, if it is something is stuck into the pipe, you can see that water is not able to move that much easily. Correct or not? So this is analogy is being used here. Okay, first listen, I will tell you. Ohm's law describes, listen, Ohm's law describes the current flow through a resistor when different electric potential applied at each other resistors. Correct. Now we are imagining, since we can't see an electron, we are imagining it as a water pipe analogy. How do you understand, sir? First, inga paranga. So water flowing through pipe is a good mechanical system, okay, to an electrical circuit. Okay, now you can see that the voltage is analogous to water pressure. I told you, the pipe, and the current is nothing but the amount of water flowing, and the resistance is what? Size of the pipe. If the more the size of the pipe, the water will flow very easily, or lesser the size of the pipe, the water will flow little bit lesser. கரெக்டாக? ஸோ அதே சேம் எக்ஸாம்பிள் தான் நான் இங்கேயும் சொன்னேன் உங்களுக்கு. அந்த இதில் பைப்பில் பார்த்தீங்கன்னா கொஞ்சம் ரஸ்ட் இருக்குது அப்படின்னா இந்த இடத்துல எனக்கு தண்ணி என்ன ஆகும், அவ்வளோ ஈஸியாக எனக்கு என்ன ஆகாது, ஃப்ளோ ஆகாது, கம்பேர் டு இந்த பைப்பில் எனக்கு எதுவுமே இல்லாத இடத்துல. ஓகேவா? ஸோ திஸ் வாட்டர் இஸ் கன்சிடர் as a current, and this pipe is nothing but considered as a voltage, and this sand pit is nothing but they are considering as a resistance. Okay, so this is called as water pipe analogy of Ohm's law. Okay, so more water will flow through the pipe where more pressure is applied. Okay, bigger the pipe, lower the resistance. I already told, no. So R is inversely proportional to L by A. If the area is more, resistance is less. If area is less, resistance is more. Okay, so we are comparing this to what analogy? Okay, because we can't see the electron. So in the next topic we will see about what is Kirchhoff law. Okay, so I hope you understand all this. If you have any doubts, you can comment me in the section below. Please subscribe my channel. Thank you.